before I introduce our guest speaker, I want to tell you a little bit about the Night Science Journalism Project at MIT. A couple of years ago, we were invited by Mr. Smart to send students to the program. We've done it 2 years now, so we've sent 2 students each.
2 students each year.
Each year.
4 now.
And so the idea is to get folks interested in science journalism. And I think a lot of people are intimidated by science and math. That's why y'all want to be media people, right? I know I did when I was in college. But it is an opportunity to see folks much like yourself working on science and talking about all the different things that they can cover. You know, it's not eerie, it's not overly complicated, it's rigorous for sure, but it's amazing the things that fall into that category or under the umbrella of science. And an opportunity to be at MIT, which is renowned for its science and research, is an opportunity that we shouldn't pass up. We have a member of the Board of Regents here at Morgan who was leaning on me forever to say, you should have science journalism in your curriculum. And we do, we have it. We just don't get a lot of people to sign up for it, so we're hoping to change that as well. There's a woman named Shirley Jackson who has recently retired as the president of Rensselaer University. She went to high school with my brother in DC, graduated from Roosevelt Senior High School. You know, yay, public school. Got public school students in here? How many of y'all graduated from a public school? Yeah, so, you know, people always say that public school doesn't produce brainiacs, but that's not true. But all that's to say, it's a golden opportunity. And I'm hoping to encourage more people to step up and apply for the program, rather than having us saying, you ever think about doing this? Asia, you ought to do that, right? So I hope that after hearing Mr. Smart today, that you all will ask him some questions and think about sort of the depth and breadth. How many of y'all read science fiction? Anybody? So understanding the science of science fiction helps you write it better. So if you have any aspirations in that area, it's a great way to start. Professor Cotman and I went up there the first year of the program, and I think he went last year, this past summer.
Not this
Earlier
past
this
summer,
year,
no.
no.
But yeah, the first year, for sure.
So, A, I fell in love with the campus. B, I was bowled over by the speakers and their journey to becoming science writers, because they didn't all start off thinking this is what I want to do for a living. So an experience like this can sometimes send you in a direction that you didn't even think was possible. And I think that's one of the key things that you want to do. So I want to bring forward Ashley Smart, who's going to uncover the hidden story behind the Human Genome Project through cases like Henrietta Lacks. Most of you are aware of that case, right? And revealing how the use of anonymous DNA helps shape modern science without consent. So I'm going to let Ashley come forward and tell you all about himself and what he's learned over the years and how excited he is about science, and hope by the end you will be too. Ashley.
Thank you, James. Thank you for that very nice introduction. Can everyone hear me okay? Yes. So I have what I think is one of the most interesting jobs in journalism. Maybe I should can I turn this one off? Is that better? We'll try this. So I have what I think is one of the most interesting jobs in journalism. And that's partly because I get to write about science. And as Dean Jones was saying, science can mean so many different things, right? So it could be physics, which is a beat I used to report on when I was starting out. It could be biology and genetics, which is another topic I'm really interested in. It could be oceanography, it could be astronomy, paleontology. But science can also be air quality and water quality. It's climate change, right? It's urban design. It's you name it. I mean, you can argue, and I will argue later in this talk, that there's no aspect of our lives that science does not touch in some way. Policy, politics, right? And so if you're covering science, you could be covering anything. And that's, in a way, the story of my job is that I can cover anything. But not only do I write about science, I also work as an editor with Undark magazine. Has anyone heard of Undark magazine? Google it. It's an excellent magazine, especially if you're interested in kind of stories about science that really impacts people's everyday lives, stories about science and kind of really interesting ethical questions. So I work as an editor there, and I get to help other writers tell their stories. But as Dean Jones was mentioning, I also work with the program at MIT called the Night Science Journalism Program, which exists to help support science journalism writ large. And in that capacity, one of the nice things I get to do is just interact with tons of brilliant science journalists, tons of brilliant aspiring science journalists. And one of the favorite parts of my job, one of my favorite things that I've done is help start this HBCU Science Journalism Fellowship program there. And so here we are, this is our most recent class. We're on the campus at MIT. And what we do is we bring students up to MIT for a week. We do a crash course in science journalism. So they're learning all the skills and the tools to report on this beat. They're actually doing some reporting on this beat. They're working on a trial story. And then we continue to work with them throughout the year, even after they leave. And so students come from places like Howard and Hampton and North Carolina A&T, and of course they also come from Morgan. So some of you may recognize the young woman in the Morgan State sweatshirt there, Alicia Robinson, who was there last summer. Some of you may recognize this young gentleman standing on the end next to me, Tavon Thomason. And so bringing students to MIT and kind of giving them that introduction to science journalism, giving them the skills, giving them the confidence they know that they can do it, but also conveying, as Dean Jones was saying, that science journalism can mean so many different things. It's a huge umbrella, and anything that you're interested in, you can find a science angle to it, right? Even if you're not a science journalism, there may be some science in your journalism. And so that's one of the things that we try to drive home. But that's been a fun program to work on. I'm still feeling a little feedback. I wonder if I can get this off somehow. Let me know if it continues to be an issue. And so my talk today is called The Value of a Second Story. Am I still on? Everyone hear me? So what is a second story? What do I mean by second story? Well, I write about science, so I think about this in terms of a science journalist and in terms of stories about science. And in science, a first story, I'll tell you what a first story is, and maybe that'll help explain what I mean by second story. The first story that covers some new discovery or breakthrough or invention, right, in science is often a story that's told from the scientist's perspective. It's the scientists who are kind of framing what's important here, what the stakes are, what the big questions are, right? And the reporters are doing their job. They're asking, all the 5W questions. They're reaching out to different sources. But it's really the scientists who are kind of framing and setting the stakes for the story. And so one example, some of you may remember a couple of years ago, the first vaccine for RSV was approved, right? And this was a big deal. I don't know if anyone has had experience with RSV. I had my son, when he was young, was vulnerable to RSV, so he had to get kind of shots to protect him from what can really be an awful disease. And a couple of years ago, the first vaccine for RSV was approved. And so this was a huge deal, right? And it was a culmination of decades of research, and it was something that was certainly going to save many, many lives, especially for the most vulnerable among us. So that's the first story. And it's a true story. It's an important story. But I also want to tell you about a second story about the RSV vaccine. And this was one that was dug up not by me, but by one of my colleagues at Undark, Michael Schulson, tremendous reporter. And this story goes back to 1966, when two young children, 14 months, 16 months old, died back-to-back, New Year's Day and January 2nd, after receiving an early experimental shot of an RSV vaccine. And moreover, they received those shots without clear consent from the family. The family was never completely filled in on what happened to the children. To the time that my colleague reported this story in 2023, a lot of people didn't even know the names of these two kids. Even the family members didn't even know what had happened with these two kids until my colleague went to them with his reporting. Tissues were harvested from these two children without consent. And so when we talk about the story of RSV and the RSV vaccine, this is also part of that story, right? This is the second story. A second story is often told with the benefit of time and distance. A second story is often told from a different perspective. The second story asks probing questions, right? Questions that go beyond the framing that the scientists give you. Questions that explore science as a social practice with social implications, right? I'll give you another example of a first story. So for this one, we go back to 1985. I'm guessing none of you were around in 1985. But a big discovery then was the discovery linking something called the human papillomavirus to cancer, right? And this was a huge deal. I mean, it went on to win a Nobel Prize, and it also went on to lead to the first HPV vaccines, which again, you know, this is a triumph of science. It's going to save a lot of lives. But a second story related to HPV, which I'm guessing many of you may be familiar with and with which Dean Jones alluded to, is that the cells used in that research were harvested from a woman, Henrietta Lacks, without knowledge and without consent, right? And similar to the RSV story, you know, even the family was kind of in the dark on this until reporting dug it up. This book by Rebecca Skloot is a classic. If you haven't read it, you should do your favor and read it. It's one of the classics of science journalism and just exquisite storytelling, important storytelling. And so these second stories are important. The first stories are important, important for the public to know. The second stories are also important for the public to know. The second stories, they'll give us a chance to bring in a different point of view. So when we talk about science and the scientific enterprise, we often think of the people who are wearing the white coats and in the labs. But really, we're all part of the scientific enterprise, right? If science impacts us. And so second stories can bring in the point of view of different people who are also part of science, but who the scientists maybe overlook and too often undervalue. So today I want to talk about a particular second story that I worked on in my capacity at Undark. And to get into that, I want to first give you the first story. How many of you have heard of the Human Genome Project? So the Human Genome Project, people compare it to the Apollo moon landing in that it was a massive effort to, a long time to pursue. Depending on how you count, it could be 13 years. Depending on how you count, much more than that. involve international collaborations with various research institutes and centers. And the goal was to sequence or decode the human genome. So when I say the human genome, I'm talking about all of the DNA that we have in our cells that give us kind of an instruction book for creating a human, right? So this is the DNA that's encoding the proteins that do all of the functions and give us the qualities that we see, or at least many of the qualities that we see. And there was a quite ambitious project to say, we're gonna decode all of the letters, so the A's, C's, T's, and G's in our genetic code of a human being. It's 3 billion letters, right? A huge, massive, almost audacious thing to try to take on. But they did it. I mean, this was an example of big science, of collaborative science, and over more than a decade, they succeeded. And so in 2000, as they're nearing the finish line, you get headlines like this splashed across the entire front page of the New York Times, right? Genetic code of human life is cracked. Refer to it as the book of life and refer to it as bringing in a new era of medicine. And these things are true. I mean, in my reporting, when I talk to people about the Human Genome Project, it's not an overstatement to say that this project revolutionized the way we do biology. Does anyone study biology or maybe remember biology from high school? I mean, you can't really do research today without using some of the tools and resources that were developed as part of this project. And so that's the story about the Human Genome Project. And there's also a narrative about who made this happen, right? So on the right here, in this article, 25 Years of Biology, we can see in the top right corner a picture of the people who made this happen, right? And that's a story. It's a true story. It's an important story. It's a first story. I want to tell you about a second story that I worked on about the Human Genome Project. And for that, we have to go back to Buffalo, 1997, March 1997. And I'm guessing many of you weren't around for this, but we can put ourselves there. We can imagine that we were in Buffalo, 1997. And a confession, this picture is actually not from 1997. It's from a little earlier than that. But let's imagine we're there. And on March 23rd of that year, we might have picked up a newspaper, right? We're journalists, so we're interested in the news. So we might have picked up the Buffalo News, and this is what we would have seen on the front page. We would have seen an article called The Great Gene Hunt. And this article would have described some of the work that was going on in the Human Genome Project. And it also would have mentioned that some of this work was being done in the city of Buffalo at a place called the Roswell Park Cancer Institute, right? And this scientist in the picture, he's at the Roswell Park Cancer Institute. And it would have talked about the project as having vast potential benefits, but also immense risks, right? And then if we had flipped through that newspaper, in that same issue, we would have seen a kind of unusual wanted ad. This wasn't someone looking for a used car. This was a wanted ad for volunteers for the Human Genome Project. 20 volunteers to participate. And by volunteers, what they really mean is they want people to donate blood samples, to donate DNA that could be used in the project. So when we talk about the human genome and the Human Genome Project, it's easy to think about it in abstract terms. This is what the human genetic code looks like. But to actually sequence this stuff, to actually decode it, they needed DNA from actual humans walking this earth. They needed DNA from real people, not abstractions, right? And so this wanted ad was calling for people who would come in, donate their blood, donate their DNA, have their DNA published for the world to see, put in the public domain, and for scientists to continue working with, from now until eternity, basically. And so if you're in Buffalo that day and you're reading the paper, oh, maybe you're intrigued. This genome project sounds interesting. It sounds important. I have some time in my day. Maybe I'll go into the Roswell Park Cancer Institute. And so you might have gone in, and even if you weren't entirely sure what this project was, they would have talked to you about it when you got there. So you would have gone through what we call an informed consent process. The informed part means they have to kind of explain to you what they're going to do with the samples and what the risks are. And then the consent is when you agree to do it, right? And so they would have explained to you the project, but they would have also talked to you about some of the risks, right? And in this case, I mean, when you're having your DNA made public, this was something that had never been done before. The risk, it was pretty hard to predict, but you could certainly imagine some things that could go wrong, right? So what if scientists get a hold of your DNA and they discover you have, a genetic predisposition for some illness, or that's going to potentially make you unfit to work, or potentially make you more likely to get sick? Then employers, insurers, they might use that to discriminate against you. So these were the kinds of risks that the volunteers at Roswell Park were told about. And they were also told that there were some risks that probably just couldn't be predicted. Your DNA is going to be the first ever DNA to be out there for the world to see. There's some risks that we can't even tell, we can't even foresee. But these volunteers were also told that the scientists were going to take steps to mitigate those risks, to reduce those risks. And one of the important things they were going to do is that they weren't going to publish just one person's entire genome, like one person's entire body of DNA. What they were going to publish was a patchwork. So they were going to get a bunch of volunteers, like 10 volunteers, and they were just going to publish little parts of, little strings of code from each volunteer, so that there's no one person making up this whole code. And that was going to make it more difficult for someone to tell who you were based on the DNA. It was going to make you harder to identify. And so if you had been there, you would have read this line in the informed consent. And it said, if we use the blood you donate, there's no guarantee that your blood was going to be used. Then we expect that no more than 10% of the final DNA sequence will come from your DNA, right? And so maybe you say, oh, okay, that sounds fine to me. You sign, you donate your tablespoons of blood, you go home, you feel like you've done a duty to science, you feel like science is going to do a duty to humanity, and you also can feel assured that the scientists, for them, your safety is paramount. They're taking steps to protect it. Let's fast forward a year, and let's go down to Bethesda, Maryland. So this is the National Institutes of Health. This is where a lot of this work is being coordinated. And in September 1998, in the fall of 98, they have a dilemma. And the leaders of this project are meeting and trying to figure out what to do. This picture is not from an actual September 98 meeting in Bethesda, but it does show Francis Collins, who was kind of the quarterback of this whole Human Genome Project. And so it might have been a meeting like this. And the details are a little hard to pin down. Even the people who were there kind of give conflicting accounts of what happened. But what most people agree on is that, one, they realized in 1998 that this Human Genome Project, which was taking decades, that they had to get it done quickly. They had to get it done even more quickly than they anticipated. And they also realized that this patchwork approach, this approach of getting 10 volunteers, sequencing all of their DNA and then combining it into this kind of mosaic, that was going to take too long for them to do. And so what they decide around this time is that they aren't going to do a patchwork anymore. They're going to take one of those Roswell Park donors, and they're going to go past 10%. They're going to go way past 10%. They're going to take one donor, and their DNA is going to be the vast majority of what gets published and what gets made public, right? And they also decide, and this is complicated, and I'm having to kind of simplify it a little bit, But they also decide that they're not going to try to go back and tell that donor about this change. They're just going to press forward. And so fast forward another couple of years, it's 2000, spring of 2000, the project is nearing completion. Again, this is a big triumph. You may recognize Francis Collins from the previous picture. Hopefully many of you recognize Bill Clinton, who was president at the time. They're in the East Room of the White House having a big ceremony. This is a victory lap for the Human Genome Project. They've accomplished this huge, ambitious, audacious thing that people weren't even really sure was possible. And this is a celebration of that and all that it's going to mean for science. One thing that doesn't get discussed much here, though, is where this DNA came from, right? I mean, we're talking about this human genome, sequencing, the DNA of a human being for the first time. Not many people are asking who that human being was or who those human beings were. And you have to be pretty sharp. You have to be paying pretty close attention. And if you look at a table in the paper that was published in this, it was a huge, landmark paper published in Nature. There's a table that describes, they're called libraries here, but you can think of these libraries as people, essentially. These are the people from whom the samples came from. They're anonymized here, of course. But it lists those donors, and on the far end, it lists the fraction of the total genome that came from each of those donors. And so if you're paying close attention, you'll see this column down here. This print is small, but this donor is RPCI 11 or RP11. RP is for Roswell Park. And on the far right column, you'll see that RP11's DNA made up 74.3% of this draft genome. So they blew past 10%. And basically everything that we were celebrating that day, the big piece of it, the centerpiece was this anonymous person, RP11, who didn't get discussed much at all. So who is RP11? The short answer is we don't know. They were anonymized for good reason, to protect their identity. But people did eventually kind of catch on to the fact that this one person was a real centerpiece, did make up the majority of this hugely important genome, a genome that's still used today for all kinds of biological applications. And arguably, RP11's DNA, his genes, are maybe the most scrutinized, most analyzed DNA and genes of any human walking this planet. And RP11 may still be walking this planet, we don't know. But tons of scientists have dug into this DNA, analyzing for everything from genetic propensity for diabetes to all kinds of other diseases. We know just from the structure of the DNA that RP11 was male. So if you hear me refer to him as him, that's because that's the scientific consensus. And scientists also feel pretty confident that RP11, just based on his genetic ancestry, likely identified as Black. Right? And so we have this first story, which is a true story, which is an important story about the Human Genome Project, the triumph that it was, what it meant for biology. But we also have the second story of a Black man from Buffalo who never clearly consented to being the centerpiece of this project that he is, right? We have this story of a Black man from Buffalo who maybe to this day still doesn't know the important role that he and his DNA played in the march of science, in the march of biology. And we can put our shoes in, we can put ourselves in his shoes, right? We don't know who he is, But we can imagine that if he were to find out today, he might be thrilled. He might be excited to know that he played such an important part. He might be alarmed to know that his genetic privacy, was compromised in this way. The ethicist that I talked to for this reporting described it as a broken promise. The promise that scientists and this was a federal project, right? So the promise that our government made to this volunteer, they say was broken. You might be alarmed by that. But I also feel like maybe he would just want to know, one way or the other. He would want to know what happened. But he was never told, and also we were never told, right? And so it wasn't until almost 25 years later, I got onto this story, at Undark and began reporting it over a long process. Probably spent half a year kind of digging up, reporting and talking to sources. It wasn't until 25 years later that this story came out. And what I discovered was not only the informed consent issues with RP11, but many of those other libraries, many of those other samples that you saw in the table, they also had, significant issues, consent issues with them that were never reported in the scientific paper. And so I spent a while reporting this story. At Undark, we're very rigorous, so this went through several layers of editing. Probably 3 or 4 different editors had eyes on it. It went through a rigorous fact check. It was read by lawyers, right? And then on the eve of the story publishing, I hear from a scientist who was connected to this story. Reaches out directly to me. And I'm going to paraphrase here, and I'm not going to name any names. But basically, they were like, I think you should rethink telling this story. Think about the harm that telling this story could do. At a moment when public trust in science is already wavering, when we have, anti-vaccine misinformation and, public trust in science is falling. A story like this, it could further damage public trust in science. And so in not so many words, he told me, he suggested, focus on the first story. Focus on the first story about all the good that the Human Genome Project has done. Don't tell the second story. That could hurt the public trust. And so one of the first things I thought was, man, I thought this was a media-savvy scientist, but he doesn't understand journalism because he just wrote me all this stuff on the record. I mean, I could have used it, right? I could have put this in the story. I didn't, because I'm a human being and I'm not cruel. But it's also kind of a fundamental misunderstanding of what we're doing as journalists, right? And I think it's a fundamental misreading of what contributes to public distrust. I mean, I think the shame. So this story is a shame. So it was. I have it up here twice. It was published in Undark, but also co-published in Stat, which is an excellent magazine covering bio and health sciences. You should check it out if you haven't heard of it. But I think the shame is not this story necessarily, but the fact that it took 25 years for this story, for the public to be made aware of it, right? That to me is the bigger shame. And if I hadn't written it, it would have been an even bigger shame if it took another 50 or 100 years, for this to come out. I think that's the real threat to trust in science and trust in institutions, right? Is when we don't tell the second story, is when we only tell the first story from a certain perspective, to the exclusion of all the other different points of view, all the other perspectives that matter, that are important. And so, needless to say, we didn't listen to that scientist who had reached out to me. We ran the story. And I think did an important public service, right? And this is, I mean, I'm biased because I've kind of always been a magazine writer. So second stories are my thing. I mean, I think first stories are important. They're great. The people who are covering breaking news, we need that. We need people documenting, what's happening, getting the who, what, when, where's, why's. But the second stories, I take a step back, look at a story from a different perspective, look at different people who have different things at stake. Those hold kind of a special place in my heart. And so a lot of the work I'm most proud of, I would say has been second stories. Here's just another example, a piece I wrote. I don't know if you remember, a couple years back there was a mass shooting, and forgive me, I hope, I should have trigger warned that I was going to bring this up, but there was a mass shooting in Buffalo at the Tops grocery store. The lone gunman basically went there to try to kill as many black people as he could. And it was just an awful, heartbreaking story of loss. And it was, if you kind of dug deeper into that story and what radicalized this person, a lot of people talked about kind of fringe race science that he was reading online that was kind of fueling these white supremacist ideas. And that was a story, but another part of that story was that a lot of the science he was reading, that he was being radicalized by, that he was referencing, it wasn't all fringe. I mean, some of it was science being published in mainstream journals. A lot of it was science being funded by NIH, by the campus I showed you in Bethesda. And so in my piece, I asked the second question, like, what is mainstream science? Like, what is ours? I say our, I'm not in mainstream science. What is mainstream science's responsibility in this? And I think a lot of people would say that they had some. I mean, they weren't out kind of spouting white supremacist ideas, but they were doing science with kind of old practices that enabled a lot of those ideas to creep in. This was a story I was very proud of. It was also a story that honestly was very difficult to write. But it's also, in a way, the story that brought me here today. This story won an award from AAAS Kavli Science Journalism Awards. And it was I meant to say this early on in my talk, but it was AAAS and the Kavli Foundation that was kind enough to bring me here to speak to you today. Another second story. This one is kind of near and dear to my heart because it touches on physics. And I used to be a physics reporter for a long time. But there's a narrative about physics PhDs and black physics PhDs that they're often kind of being squeezed out of academia, either because academia is unfriendly to them or because they just can't cut it. So they get their PhD, and instead of going on to take a tenure track position at Morgan or Johns Hopkins or University of Maryland, they're leaving. They're being squeezed out. And I think that's a story that has some elements of truth to it, but there's a second story about many of those black physicists who are leaving, and that's that they just want to. There are other things they want to do. And for this story, I talked to several black physics PhDs who decided after they got their degree, they wanted to go and teach high school, or they wanted to go and teach at a community college. And this happens disproportionately often with black physics PhDs. And I found out it's definitely not because they can't hack it. And it wasn't so much because, academia was unfriendly. It's because they wanted to be in front of a room teaching kids physics, right? And so to get those stories out was important to me and meaningful to me. And so, again, the first story is important, the second story is important. I hope that some of you all will write some second stories. I really hope that some of you all will write some second stories about science. And And along the way, I'll just share with you some of the things that I feel like were important lessons for me that I picked up, and hopefully it can mean something to you as well. The first one, and maybe one of the most important ones, is that every story is a science story. And you hear many science journalists say this. Every story is a science story, meaning that in almost any story, there's some science element or some science angle, there's some way that science touches the story. And I haven't had anyone give me an example of a story that has no science element to it. So if one of you all want to stump me in the Q&As, you can give it a try. But really science, and by science I mean both the act of gathering information in a scientific way, but also the applications that come out of that science, it really touches our everyday life. And a corollary to that, I would say, is that no story is just a science story, right? So when we're reporting on science, we aren't just reporting on kind of the mixing of vials that's happening in the lab, you know, the experiments. Science is done by people, it impacts people. So for every science story, there's also a social story, right? And there's a story of the implications of the science. There's a story of the decision to ask this scientific question and not that scientific question. And I think the more that you can kind of come to understand that as a science writer, the better reporting you can do. And along those lines, there's always more than one kind of expert. I mean, when we think of experts for a science story, we also often think of, you know, the PhD researcher who's in the lab, who knows this stuff, you know, inside and out better than anyone else. But we're all a part of the scientific enterprise, right? If we breathe air, if we drink water, we depend on environmental protections. If we've applied for a loan and they're using AI to determine whether or not we're, you know, a safe bet for a loan or not, like, we're all part of the scientific enterprise, and that we're all impacted by it. And often to tell a rich story, to kind of tell a multi-dimensional story about science, you have to talk to more than just the people who are doing the science in the lab. Bring yourself to the story. I mean, this is, I'd say the first one was important, but this is maybe the biggest one, right? Especially if you're doing a second story. And by second story, the second story being a story that's asking kind of different questions than the first story. Bring yourself to those questions. Ask questions that no one else is asking. Be curious, be interested. This doesn't necessarily mean put, you know, right in the first person, put yourself literally in the story, but bring your set of experiences, your understanding about the world, your curiosity about the world, bring that to your reporting, bring that to the way you tell a story, and you're going to tell a story that's going to be unique and genuine. But be fair. I mean, this is just, I mean, as journalists, we know this, right? I mean, you have to be aware that you have blind spots. You have to be willing to be open to the possibility that your idea about something may be wrong. I found that I have to be willing to hear people out, even if I don't think I'm going to agree with them, right? I try to be fair to every person that appears in a story of mine. And sometimes that even means reaching out to people whose views make them difficult to reach out to, but whose views are also important to have on the record. And then also be persistent. And this is true in science journalism, this is true in journalism, this is true in life. Chase a story to the ends of the earth. Don't give up on getting that source. Don't give up on getting those documents. Don't give up on getting a full, complete, compelling story. But also, you know, be persistent in your growth and development as a journalist, right? I feel like every day I come in, I've been doing this for a long time, but I feel like every day I come in thinking, how can I get better at this, right? And so that part never stops. It never should stop. And so I hope that some of you all, Dean Jones made a pretty good case for thinking about science journalism or bringing science into your journalism. I hope that I've been able to make a bit of a case too. And I hope that some of you all will take this as a starting point to want to learn more and do more. And if that's the case, there's no better place to start than the Open Notebook. Has anyone heard of the Open Notebook? No? Google it, go to the website. I have, full disclosure, I'm on the board of the Open Notebook, but it's a project, it's a resource that's been around for much longer than I've been on the board, and it's just it's a trove of information, of wisdom about reporting on science. There's a pitch database there. If ever you guys are thinking about pitching a story, especially pitching a story on science, there's a pitch database with like hundreds of successful pitches, and people had just donated their pitches to the Open Notebook so that you can read and see how they did it. Pretty much any science outlet you can think of, there's a successful pitch to that outlet that you can look at in the Open Notebook when you're thinking about pitching a story. Incredibly valuable resource. Shout out to the AAAS Mass Media Fellowships, which is kind of more geared towards students who are coming from the sciences and looking to get into science journalism. But it's one of the best. There are lots of internships and fellowships around. Based on my experience of people who have been through them, this one is one of the best, I think. Earl could probably attest to that. And also AAAS Diverse Voices in Science Journalism internship. A good colleague of mine had ran this program for a couple of years, and I think it's another just tremendous opportunity if you're looking for just kind of an introduction, an entry point into this field. There are several graduate programs in science writing. If after you finish at Morgan and you want to continue your education doing graduate studies in science writing, MIT has a really strong program. It's separate from the program that I'm in, but I know the director very well. And I also know that one thing he's very proud of is that they've managed to get this program fully funded. And so if you get into the MIT graduate program in science writing, you don't pay a penny for tuition, you don't pay for room and board. As a matter of fact, his motto, his belief is that you should leave the program with more money than you had when you came in. And that's because you also get to do an internship as part of the program, right? So there are several programs. UC Santa Cruz has a very popular graduate program in science writing, NYU as well. There are others out there. National Association of Science Writers, Council for the Advancement of Science Writing are two big organizations. They put on a big conference every year called Science Writers, where hundreds, typically 500, 600, or more science writers come together and talk shop, also network, and also learn about kind of new cutting edge science. It's a fantastic place to meet people, fantastic place to meet editors. The conference is actually happening next week in Chicago, so it may be late to go this year, but it's something to think about for future years. And then, last but definitely not least, we have our HBCU Science Journalism Fellowship at MIT, which Dean Jones so kindly mentioned in her introduction, and which for me has just been a really fantastic experience. I think we bring in a top-notch faculty of journalists to run the program, journalists for places like The Atlantic and from STAT and from various journalism graduate programs come in for 1 week just to work with the students, the small group of students who are there. We have mentors from places like National Geographic, who are going to work with you throughout the entire year. And it's really a close, kind of intimate program. The fellows get to know each other well throughout that week and throughout the year, and kind of form lasting relationships. And there's a lot of just kind of one-on-one instruction. And also it's in Cambridge, which is a nice place to be in the summer. And so if anyone's interested or curious about that program, ask me, come find me. And then I just want to, again, thank Dean Jones and thank Assistant Dean Michael Kopman for bringing me here, and also for being so instrumental in helping us get this fellowship program going. I want to thank Earl Lane and all the folks at AAAS for putting on this lecture series, for making it possible for me to come here, and also for putting on what's really become, a prized and valued Science Journalism Award. It's something that means a lot to this entire community. And I want to thank also the Kavli Foundation for their support. And thank you all for bearing with me, for sitting there and listening so patiently to this talk. And so I guess maybe, Michael, we have some time for audience questions, if there are any. Yes.
Hi, I'm Jai Williams. I'm a multimedia journalist major here at Morgan. Thank you for coming to talk to us. Just a quick question. I just wanted to see your perspective on this, just talking about how you bring yourself to your stories. What does that mean to you?
Yeah, so I have to preface this by saying I have a real aversion to first person writing. So I try not to put myself in the prose. But I think I bring my specific brand of curiosity to the reporting that I do and to the questions that I do. And so, for instance, I mentioned the story about the Tops shooting in Buffalo. I had seen a lot of stories, a lot of journalists covering that shooting, including a lot of science journalists. And I felt like the questions they were asking, it felt like they were missing something. And I think maybe part of what gave me a different angle was that, frankly, as a Black person, a lot of what was being spouted in that manifesto, if you remember the person who wrote the whole manifesto, it was being aimed at me, and not just me, but the people I grew up with and people I went to school with and my family, right? And so I feel like that just led me to think about it in a different way and to ask different questions, and maybe also to bring a different kind of skepticism, to what people were saying. I think that's for me, when I talk about bringing myself to the story, for me that's kind of the biggest element of it. But there are other ways to bring yourself to the story. In some, especially, essayists are really adept at kind of literally putting themselves in the prose, and that could be valuable and effective too. But yeah, I don't know if that helps answer your question, but yeah.
Thank you.
Yes.
My name is Carl Dennis. I'm also a multimedia journalism major. So I wanted to talk more about you saying the medical misinformation, and that scientists call you saying, hey, that's not a good idea because it can be taken the wrong way.
Yeah.
Where do you find your sources in the age of misinformation so that you can build trust in the community when it comes to science journalism or health journalism?
Yeah, that's a good question. I think a lot of source building takes time. It takes kind of just getting to know a field and kind of the dynamics, the social dynamics in that field. A lot of it, some of it comes with doing good reporting, right? And so, for instance, no one asked me how I learned about this whole Human Genome Project consent issue that had been buried for so many years. But that first arrived to me as a tip from someone who had followed my reporting and felt like I would do a good job telling the story, and kind of entrusted me with that tip. And so I think sometimes good reporting breeds good reporting and kind of and more trust from sources. And also just asking around. I mean, one of the things I have to kind of hammer home to young journalists sometimes is that if you don't know something, even if you don't know who to talk to, just get on the phone with somebody and ask them, right? And even if the person you get on the phone with is not the best source, they may be able to point you in at least a direction that brings you a little closer to a good source. And so, yeah, whether it's the phone or email or text or Zoom, just talk to people. And that can kind of help to get you over the hump. Yeah. Is that helpful? Yes.
Hello, my name is Asia Matthews. I'm a senior multimedia journalism major. My question is, what was either the first story, science journalism story you wrote, or the first story that kind of made you believe, okay, this is what I want to do for my career?
Yeah, that's a good question. It's hard for me to go back and remember now. I can tell you one that was really fun, where I was like, I don't know if it was the first story that made me feel like it's what I want to do, but it was a story that made me feel like, wow, I get to do this. And that was back when I was reporting on physics. I got to do a story on a guy named Danny Shechtman, who had just won a Nobel Prize. He had done research on, I believe it was quasi-crystals. And I was one of the first people that got to interview him after he won the Nobel Prize. And he spent a lot of time kind of talking to me about his work. He was very generous with his time. And it was also just a really interesting and fun story. And for me, someone who I never thought I'd come within sniffing distance of a Nobel Prize winner. To be able to do a story like that, where it's like, oh, I'm talking to someone who's done something huge, and he thinks that what I'm writing is important enough to spend time and talk with me. That was a fun moment, and I really like the way that story came out. I still feel pretty proud of that one. Yeah. Any other questions? It seems like maybe people are heading off to class. Were you going to say something, Michael?
Yeah, thank you so much for being here. Thanks for taking the time out. Really appreciate it. Wonderful lecture. One of the things I just want to share, I know just a few of us left, but a lot of students often tell me when they look at newsrooms, they don't see themselves in science work. And so one of the questions I just wanted you maybe just to address this a little bit is, what can students of color bring to the table in science writing, and why is it important to have their voices?
Yeah, I mean, I think there's a lot that you all could bring to the table. I think it's very important to have you there. Especially, this is just one example. I mean, just in the past 10 years or so, I've seen a lot of outlets become much more interested in covering stories about environmental justice, health disparities, climate injustice, right? And these are often stories that are impacting our communities disproportionately, but that we don't always have the journalists with kind of the nuanced understanding of those communities reporting. And so that's one example of kind of how there's a need. I think there's a gap that needs to be filled. But I also think we can make a difference reporting on any topic. I mean, we can make a difference reporting on astronomy or physics or oceanography. I think, having a sense of community there, also having us in the newsrooms where decisions are being made about what stories are worth covering and what stories are not worth covering, that's important. And I think the more that the newsrooms, especially in science journalism, where, as Michael pointed out, it really is, we really aren't doing well enough at all in science journalism. But the more that these newsrooms and outlets kind of reflect the communities that we're trying to serve, I think the better journalism we're we're going to produce, right? And so, yeah, I'm glad you brought that up. I think that's super important.
Thank you.
One more question, yeah.
I have questions, I'm sorry. I get excited. So with the political climate right now, I know
Yeah.
that science journalism is extremely needed right now. How are you guys combating all the false narratives that are floating around? For example, we don't need the weather department in the government, or or acetaminophen are bad for children. How does science journalism combat that?
Yeah, so I'd be lying if I told you the answer, but it's certainly a conversation that is happening in the circles that I'm in. And I think one thing that a lot of people seem to believe, and I probably believe this too, is that as science journalists, we often do a good job of explaining the product of science, like what comes out of it. We don't always do such a good job of explaining how it works. I think a lot of the public has a misunderstanding of how progress in science happens, and how it's kind of this systematic chipping away at uncertainty, even if nothing is proved. It can be, we have evidence that gives us certain ranges of certainty about things. That the science is slow sometimes, right? That it accumulates over decades, that it's one paper building on top of the previous paper, which was building on top of the previous paper. And so I think one idea that's come up a lot is that we can do a better job of kind of explaining the process of science and helping the public understand the process of science. And maybe then they'll understand why that fundamental research that's going on, being funded by NIH, or those clinical trials that are being funded by the CDC, why that matters to them, and why that, even if it's not today, eventually it's going to matter, in their lives, right? And that fundamental research kind of leads to these applications that are important to them. But it's a good question. I don't know that that's a silver bullet, right? Because we're doing this reporting in this broader context of political polarization and misinformation, but also wielding of power in different ways. And so I don't know if that, it may be too simple to think that's a silver bullet that's going to solve it all. But that's definitely a thought out there. Yeah, I'm glad you asked that question. No more? Any more? All right. Well, I think Michael has walked out of the room, so I guess I'll just say thank you all for coming. It's been a real pleasure talking with you, and do follow up. If you're interested in coming to MIT for a week, do follow up with me. I'd love to hear from you.